Hi, this is going to be a very brief demonstration of some of the new features to the Tuna Tin S Arduino Nano Sketch. This is version 2.3.0. It has a number of new features in it. First of all, we'll go ahead and apply power, and you'll see the splash screen comes on, and it defaults to this frequency. You can set any default startup frequency that you want, and we'll explain how to do that in a moment here. The use of the encoder is pretty standard. You can go up or down. It defaults to adjusting the 1 kilohertz. It says it right on the bottom line there. It's 1 kilohertz steps, and you'll also notice that there is a underline cursor under the digit that's being adjusted here. And if you want to change the step, you do it with a quick tap on the encoder, and you see it change the steps. You can go 1 hertz, 10 hertz, 100 hertz, 1 kilohertz, 10, 100 kilohertz, 1 megahertz, or you could also step band. And stepping band, the way you would go there is you just again click the encoder, and now it'll scroll through all the bands all the way up to 222 megahertz, and starting down as low as the 2200 meter band, which is 137 kilohertz. So that's how that works. Now the 60 meter band, of course, we don't have individual what we have there is 5 channels that we can scroll through. We can't adjust by kilohertz there because it's a channelized band for us. And I'm going to go back to 40 meters. And let's go back here to 1 kilohertz steps. Okay. You can change the default frequency very easily just by, for example, if you want to go up and you want to change it to 7040 or any other frequency on any other band. All you need to do is you need to hold in the encoder switch for about 4 or 5 seconds, and then let it go, and it says saved. So when we reboot this, you'll see that now it'll start up on this frequency. I'm going to go ahead and do a reboot. And there it comes now on this default frequency. The startup frequencies on all the other bands are the default QRP calling frequencies. One of the other features that we have here is calibration, and the way we calibrate is you hold the button down for about 2 seconds here, and it'll change to calibrate mode, which you see there. What we do to set the calibration here is you get a receiver that's tuned to WWV, and then you listen to the heterodyne in the receiver against the 10 megahertz reference signal you have, which would be WWV or any other 10 megahertz frequency standard. And then you adjust this dial until you get a 0 beat. And I know on this particular one here, that's pretty much where it will 0 beat. What you do then is you again hold this button down for about 4 or 5 seconds, and it saves the calibration and it applies it. So now your dial is accurate to within 1 hertz, and it's actually 0.1 parts per million over the entire frequency range. It's quite good actually as a secondary frequency standard now, this VFO sketch. Another feature that we have is a built-in keyer, and I'm going to go ahead and turn on a receiver here, and again we'll go back down to the frequency we were on before, 7030, And I'm going to go ahead and turn on this switch here. You'll notice also there's a receive and a transmit indicator in the upper right hand corner. Also look in the lower right hand corner, it says straight key. I can now key this. There. I'm doing this with my paddle. Doing it as a straight key. To switch over to electronic Iambic here, what you do is you just hold the button down for a little bit over 1 second, like that, and you'll see now what you see in the lower right hand corner is the speed in words per minute. And that is adjustable. To adjust that, you just push down the encoder and then turn the dial. And you can see you can go down as low as 8 words per minute, which is of course really slow. Or you can go way up to maximum of 40 words per minute. Let's see what it sounds like up there. So there, I like it at right around 20 words per minute. So, the other thing is to be able to key, to get the dots and the dashes in there, I am keying pins D5 and D6 to ground from either side of the paddle. And if you want, you can also connect a piezo buzzer to pin D9 of the Arduino Nano, and it will give you a side tone as well. So you can have an internal side tone. I'd like to get any feedback if anybody can try this, and it's available for download if you want to go ahead and try that. Remember, you do need to wire a 3-contact connector from your paddle with going from D5 and D6 to ground for the dots and the dashes on the paddle. And that's it. Thank you very much.